Hello, do you hear me well? Yes, good. Welcome, and thank you for attending my session. I hope you will find everything you expect and maybe even more. So let's start. The talk, I think, was already mentioned, the name of it. We will talk about DDL locking mainly today and the impact of schema changes that is related to this and how we can reduce the downtime that might be related to it as well, and a little bit of MVCC and more. So who am I? I am working at Zeta. It's a startup, and I also have other responsibilities in the Postgres community. I recently got recognized as a contributor, and I run Prague Postgres Meetup. If you are living in Prague, how many of you are actually from Prague? Yay. And did you know about the meetup that we run every month? No. Okay, so that's perfect audience to actually promote it. So I run this together with my friends, that is, some of them are already organizers of this conference as well, for over 7 years now. So please join us. We had a hiccup between the pandemic years, but we are back full force. We do it every month, except this month because we have the conference, and we skip the summer months and Christmas time. And what else I do? I also run a developer community in Turkey called Kadın Yazılımcı, which means literally direct translation women and developer. And we organize also conferences, and I'm part of the new initiative of Postgres Diversity Initiative to make make Postgres more welcoming for everyone. And yeah, I think that's enough about me. We just can talk more. Also, I wanted to show that I actually can say things in Czech language. It's a bit hard for me to learn the language, but I'm really trying. So I can just say, bydlíme Praze, 8 let now, and before I couldn't even say anything. So I feel like slowly I'm able to communicate myself. And this is me in the when I run the Postgres meetup, all these photos from over the years when I was much younger and more different. And the next meetup, if you want to join, you can take a picture of it. It's on the meetup platform, so you can find it as well. Okay, so agenda, I already actually mentioned this, like what are the topics that we will be talking about. It's mainly about like what are the logmos that are related to DDL changes, and how we can actually reduce the impact when we do these changes, and what are the mechanisms that we probably related to it, like a bit of about Postgres log queue, a bit about like the MACC, just like briefly. And at the end of the talk, I will mention an open source tool that we develop in my company. It's an Apache licensed tool, so you can just contribute, and we will be happy if you contribute. But yeah, we will also mention this talk at the end, tool at the end. Okay, so first I wanted to talk like logs in kind of like theory, because when I decided to make this talk, I was thinking, logs, like I should make some sort of analogies around the physical logs in the physical world. But they are literally not, for mainly how we use the real life logs is for security purposes. But in Postgres, this is mainly for controlling concurrency. So they are not related in that sense. But I bought some books about log picking and Persian logs and history of logs and something. But what is kind of what I learned a little bit from those books, that to be able to pick a log, you will have to understand its inner mechanisms like tumblers, pins, how they work. And if you make the correct movement in the positions, you can actually unlock those logs without having a key. So same way, if you want to understand how Postgres handles this locking, you will have to understand some sort of internal mechanisms of Postgres. Like that's how I think we'll have to learn a little bit about MACC, how we handle the transaction isolation a little bit, and how the log queue works. So it's in a way related, that you need to be understanding to be able to log pick. And that's how I feel this talk is important too. We will have to understand the concurrency concept in Postgres. But of course, nothing in life, and either in the physical world logs or Postgres logs perfect. So it can be a door log or a like access share log. So you will have to know its limits and like know where to actually impact these things. Okay. So Postgres has this term called multi-version concurrency control, which is a mouthful to say, but I'm sure most of you already know. Is there anybody who didn't hear this term before that uses Postgres? pretty much everybody knows, so we don't really need to talk about it. And it is not specific concept for Postgres. It's adopted by many databases and some other software projects as well. So what's the purpose of it? Main purpose, when you think about it in high level, we are trying to make sure the writes are not stopping the reads and the reads are not blocking the writes. But how we do it actually, when we have, let's say, an update operation or insert some change in the data, instead of replacing this value in the same row in place, we create different versions each time. So basically, a transaction that is running has a snapshot of one version, but when the other, let's say somebody is trying to write, they can see the other version and keep writing. Or if some other backend is trying to read, they can keep reading. So in that regard, for DML type of operations, like what I mean, like modification operations, like, I don't know, updates, deletes, inserts, merge, and so on, this mechanism is perfect. I mean, it has its own issues, but it is good enough to stop like unnecessary locking that is probably would be related if we didn't have this mechanism. But what it doesn't stop us that we still have to have lock. Like you might achieve this like, okay, reads not blocking writes, writes not blocking reads thing, but even like in select, it can still have the lightweight lock on the different objects like tables and rows and types and so on. So good to know that we have this for some specific use, but it will not actually solve everything. So we will not able to avoid locking altogether just because we have this. Okay, so there is like a kind of, it's good to have some sort of example, because when you talk about it in theory, it's like not so clear. I don't know if it's very readable, but there's a screenshot that I actually made a scenario to explain you a little bit how it actually works in practice. And in Postgres, the default isolation level is read committed level. That is like lowest isolation level that we provide, and it can go to higher transaction isolation or serializable level. This example is based on the default behavior of Postgres if you didn't change the isolation level. So this is, you need to remember, this is the example for read committed, basically. So what do we have here? First, I have a transaction that is like 100 and 101. The first transaction is just like starting. It's getting a snapshot for the select statement that it does, and it sees there's an Alice. Its salary is this 50,000. And there are some internal columns that for each time when a new version created, Postgres has actually some sort of information that it actually marks in the system. Those are like xmin and xmax. Probably those are important here to mention. The xmin column is like when a transaction created this version, it is the number of the transaction ID. So that's the xmin. And when a transaction comes in, like let's say when we create another version and the transaction which actually deleted the other one is filling the xmax value. And I think this too is enough, and there are more, and like we can talk about it more, but this xmin and xmax, if you know it, that will be probably enough for this purpose of this example. And so when we come back to our example, Alice's salary is 50,000. When we have the first transaction has the select, it can see it as a like 50,000. And then there's a second transaction, which is the 101, this transaction ID 101. It is coming and updating the salary to 60,000. So what does it do? Instead of replacing 50,000 to 60,000 in place, it is creating another version. So we have two versions now, two row versions. An old version, we marked it with the xmax 101. And now new version we created, because the creating one is the 101 transaction, so we made the xmin 101. And when the second transaction actually commits it, even when we do the select within the same transaction in the 100th transaction, we will see the 60,000. But until it commits, we will still see the 50,000. So the second select on the left, you can see it is still seeing the 50,000, even though we updated in the other one. But once it is committed, this transaction will actually see the one that is committed. So this is how the behavior of the read committed works. But I think it's a good example to explain like how it works. Basically, every time a statement starts, you get a new version, new snapshot. And then when it's committed, you can actually see what happened in there as well.
I think this is like kind of basic, but it says what it is. But not like everything comes with some sort of problems. Easy problems that we can think about MVCC, that these rows are accumulating, right? Some of them are not used, or maybe one long transaction is using one version, so it's kind of like maybe used, but what does it do? It first size of the table index, there's a bloat risk, and something needs to, clean this up and reuse the space maybe, and then acclaim this. And that's why maybe previous talk mentioned as well, there was this vacuum practices, how we need to actually tune this auto vacuum for different size of tables, different type of practices there is. So we need to be mindful, okay, this is a perfect solution, but it's not perfect. It has some implications that in the system, so we need to be aware of what it can be. So regular vacuum maintenance is really important if you want to avoid, bloat and size increase and so on. So it needs to be planned properly when you do operations. Especially when you do DML, you need to be aware of when you run a delete and update, it has an impact on your system. Okay, but not to end up in the negative note, since we have this MVCC mechanism, we can actually make sure that there are no transaction isolation is in a level that we actually have in Postgres, and we still keep serving in the high accuracy with multi different writes and reads happening at the same time. So that allows us to run a production system under the high concurrency model. Okay. So why do we actually log? Because to be able to log in concept, if you are logging something, whatever type of the log that you are doing, what it will reduce to throughput, right? So this means that it will increase the latency, then it will be actually causing probably loss of performance a little bit. But you have to have some sort of logging because you want to make sure you are providing some data that is consistent. And to be able to have this sort of isolation, to make sure that things are correct, you don't return different values that you don't want to show. You don't cause the dirty reads, phantom reads, all these kind of issues that come with not having the isolation levels properly. You have to have some sort of agreement. And that's why we have locking. And when I was thinking about the talk, what if I thought there must be two ends to this, right? What if we don't lock at all? This is one extreme. And what if we lock everything? And what if we lock everything is really clear that it's not for our, nowadays, that's not possible, right? It would be possible if there was a one user using, let's say, one accounting system running one report query a night, it never touch in the same resources ever. It's perfect. It could be locking everything, do everything in an order, but it doesn't work. So that's not an ideal case. And what if we lock what if we never lock? And that was also a cause of chaos, basically, because imagine the simple scenarios, there's a finance department, they are trying to do some, average, and then HR is entering some salary, new updated salary, and then somebody is trying to add a column. Even though in Postgres, they're now adding a column, it needs to have a log. But imagine that we don't have any of these things. Catalogs will be messed, and you would get the aborted transactions. Yeah, it will be a hectic thing. So we don't want to end up that either. So there must be a balance that we have to strike to be able to keep things in an order and we respond correct things. Okay. But today's talk, there are multiple levels of different types of logs in Postgres. The ones that I'm focusing mainly will be about DDL operations, and those are related to schema changes or maybe maintenance operations. So those are the ones that of the interest for today's talk, because most of them are need strong logs. So it's really access exclusive logs. And when you hear this access exclusive, you need to be scared. You need to know that what kind of things that it can cause to your system. And that's why I think it's important to cover this part a lot, because I don't think nobody, let's say, when we created a database, there's a schema, it never changes. This doesn't happen, right? We have to, change the default, maybe the way that you design the schema. These are evolving things. They are not static things. So we have to have a mechanism that we have to think that, okay, I will do maybe alter table at column something, but I have to have an understanding okay, when I run this, what happens in the background, what kind of impact that it waits for me. And that is usually strong logs. So we'll need to learn about it a bit more. And there is a good thing though. Let's say Even in the same alter table, say add column command, subcommands of this have different type of log modes. So not everything gets the same level of log. There are like really intricate details there. So you can be sure that when you run something, there's probably a way to maybe reduce the impact of this operation. So if you plan carefully the operations, the statements, you will have better chances of handling this. Okay. So yeah, in the presentation, I also show it here that when I run these commands, alter tables, it's not only blocking other DDLs. It might also block your selects even. It can block your updates. So you need to be aware that, you can just cause a shutdown to your system in a way that you don't serve anymore. So it's important to be recognizing this impact of it. Okay, so up until this point, we talk about some, generic explanations. And for the rest of the talk, I will have this key takeaway. So if you don't take anything from the talk, just take this with you. So first takeaway that I created is like MVCC will definitely protect you from writes locking reads and reads locking writes, but it will not protect you from other object locks that are taken. So that is an important, I think, information. That's why we need to learn, and different DDL commands will have different varying level of locks, and that's important too. Okay, so what are these locks? You can see in the documentation clearly, but I put them in a like some simple table form, and I marked the ones that are kind of pinkish purplish. Those are actually related to DDL level. The ones are above that can be created by the DML operations, for example. Row exclusive and above is like mainly like access share is select, and then there is row share is a little bit like more restrictive. That is like for select for update and share. It goes down and kind of increases how strong this lock is and how much restriction that happens. So at the bottom of it, when we have the access exclusive already, this is the strongest, and it can be, the operations like drop table, truncate, alter table, different modes, vacuum full. And this is the one that actually blocking all concurrent access, so it will create like downtime for you if you are not careful. And but the first top one, for example, for when you have a select operation takes this lock, and it can actually, multiple transactions can hold this. It doesn't conflict with other operations. And so it's the most, least restrictive. It only conflicts with, access exclusive conflicts with this one too. But the rest, you need to understand different levels of restriction. Okay. And there is actually a very good matrix in the documentation. It shows all these lock modes, like which one actually conflicts with which other. I think that's more important than knowing which statement will acquire which lock. That's important information, but it's easier to find than understand which one is actually not working together with each other, so that you can actually think about your actions properly. So their interaction is more important than which statement, in my opinion, takes another lock. Okay, so there are like some few things that we should understand here. Access exclusive, when you see this, you know that it will conflict with everything. It will conflict with selects too. But Postgres, it's like Postgres, of course, doesn't really act like it doesn't have any mechanism against this. So if it can take a weaker lock, it will always choose the weaker lock. So there are some optimizations in the Postgres already. If it can take it, it will take the weaker version of the lock. And another important thing is maybe to remember that once a transaction, let's say we acquired a lock, and until this transaction ends, it will still keep the lock, even though in the same transaction, let's say it doesn't need to actually have those. There are multiple statements in the transaction, and it doesn't need to have that level of locking. But if you start a transaction with an alter table that take already access exclusive, and in there you have also update the table stuff. For that, normally you wouldn't need to have like some row exclusive would be enough. But since you're holding the transaction, you actually block the whole transaction log, even though you don't need it. So the best practice here is like if you are doing a DDL change, don't combine them with the DML type of changes, other type of changes that doesn't need to have this much of a high restrictive log. So that is, I think, really important information to take from here. And probably I mentioned that one in the takeaway too. Yes, don't mix the commands that might need stronger logs with the weaker logs, that you are kind of shooting in your leg. If you are having a transaction, and during this transaction, you will hold this log unnecessarily long, and you will not serve unnecessarily long. So divide those things, and don't block based on the whole transaction. Okay. So, and then also there's another concept, of course, that are related to it, how these logs are actually interacting with each other, how Postgres is managing them, the log queue. So let's say when a transaction comes and it tries to acquire a log, but it's already taken by another transaction, this needs to wait. So until this other transaction finishes what it's doing, this can't acquire the log, and it will be waiting indefinitely. If you didn't set the log timeout, it will not stop. It will just wait and block everything else that is coming after that. And that is actually a bit hard to grasp, because you wouldn't expect, for example, having a select query holding a log, and alter cannot get that log, and that they conflict. So a select can actually hold the log that belongs to the alter table, but since this alter table log conflicts with pretty much everything else, anything that comes after, it can be a select, it can be any operation, it will block. And they will just queue behind each other, and then if you didn't have anything set, like log timeout, for example, you don't have any value, then it's kind of doom scenario. You just need to figure out what is wrong. And it's also really not easy to understand, because we used to see this. You would expect to see these things in PG logs, but you don't see them. So you have to actually find out which process side is kind of blocking what. So there are like PG blocking PID, then you can actually see it, but it's not so easy. Like, I mean, once you know how to search for it, it's okay, but better to not be in this position. So there are things that are like basic, simple things that you can do. Set the log timeout, especially for the DDL commands, because for the other commands, you probably really don't need to think about it. But before, like when you are running this DDL commands, you need to be aware that there's a risk that because of this log acquiring waiting thing, it will be indefinite process. But then you set the log timeout, let's say, this long-running select is still running, and you are trying to do your alter, and then you get the log timeout, and your DDL failed. You couldn't do it, timed out. But then you need to have a mechanism. So if you get this timeout, you will have to have some sort of logic behind the implemented. So you have to have a retry logic, or you have to run ticks again, basically. So planning is important. Yeah, basically, you are not safe again. Okay, I set the log timeout, I'm done. No, you still have to have a plan in hand for these kind of things. Okay, and then that brings us to basically takeaway 3. That was what I was explaining. To stop things from waiting forever, you have to set this log timeout properly, and yeah, especially for DDL commands, because in a way that why is important. I don't think when you have an application, it changes it as a column and so on. It's not so common. Like most of the applications, they read it, they update a value. You don't really do schema changes through, I don't know, your customers. They don't really do this kind of changes when they use your application. That's why, in a way, we have in charge. We are in control, so we can actually plan these things. And if you know that this DDL failed, if there's somebody that's handling this or some process handling this in your company, you can actually have mechanisms to deal with it. In a way, it's better, because imagine if we had to think about this for every operation. Luckily, we don't need to. Mostly, if you are covered for DDL part of things, you will be okay. But of course, you don't want your users to get timeout, and applications rarely differentiate what type of database errors that comes, so some things will not work, people will not understand what's happening. So yeah, better to be careful. Okay, so again, to kind of make it more clear, I wanted to have a simple example to reiterate what I was saying before. Just to say the same example, basically, if you have a long-running select, and that holds an access share log, but this access share log is conflicting with the command that I run under alter table detach partition. So this log needs an very brief access exclusive log, but it cannot get it because it is actually conflict with the select above that is long running. And then since they are conflicting, this alter went to the queue. And then afterwards, some 30-20 backends coming, and they are also trying to do a select, and they're also queuing under the alter. So until this long-running query and the alter finishes, we were not able to access this data. We blocked the access to this data. Nobody can do selects and so on. So that's why it's important to actually also monitor your long-running basically queries, because I know that so many people got issues by just thinking a simple select. What can it happen? It's just running there, fine. Yeah, but it is not. It has implicit reactions that it can create that you have to be aware of it, especially before you are doing some DDL. So that's important. I think looking at your long-running transactions, and before you actually run these changes, you have to be aware what's happening in there, because this cumulative weight can cause a lot of issues. Okay, so that brings us to the takeaway for, as I said, just plan these things. They can actually, during the schema changes, any long-running query is a scary thing. Okay, but so these are the things that are the yeah, worth mentioning. But is there a way to actually maybe get around these issues? There are. So basically, you need to think about like how can I do my operations that will maybe avoid some of these locking issues. And rule of thumb is like if you are getting to an access exclusive lock, try to minimize it so that you don't get it to that level, or maybe you take it a brief amount of time and then actually continue the operations, or find a way that doesn't actually get that level of lock. So the duration is important because if you just briefly have this lock, do what you need to do, and then continue, it's still acceptable because you have to do it. In some operations, most of the DDoS operations, you actually have to take this lock. But it depends how much you will actually hold this lock. So it's important, the duration of it is important too. Okay, so I wanted to give some example, how to make things maybe a little bit better. The very common, I think, everybody knows this concurrently commands, right? And use this if you can, because if there is a version of a statement that doesn't have concurrently versus having concurrently, this will be less restrictive for your database. But then when you use the concurrently, it also comes with like its own issues, right? Because these are not transactional, because normally when you don't use concurrently, the statements are transactional, but these ones, if you start it concurrently, you can't roll it back. So that is not so great. But it will be reducing the issue that we are talking up until now. But you need to, again, when you use something, when you decide to do some solution in your database, you need to be aware what kind of implication that brings. And this brings that things might not actually end. You know, you create the index concurrently. It has like multiple transactions itself. It divides, Postgres divides it. And you don't know, like it maybe just ended up, it failed. And you have to be aware of it. These things might fail. They might never complete. So again, you need to be aware of it. And then there are solutions like, for example, for this alter detach partition concurrently, if it fails, there's some command called finalize. So there are ways to finish these things completing successfully, but you can't just say that, okay, I'm just running everything concurrently, I'm done, no locking issue, I don't have anything to think about. You have other things to think about then. But yeah, so use these things, but treat them with care. Know what's happening actually when you switch from, I don't know, alter table detach partition to concurrently. What happens in then? Because there are different things happening. There are different levels that we still have to use access exclusive, but it divides it and then use its lower lock and then use it again when it needs to, because there are multiple steps happening when you use concurrently. Okay, and then again, so another effective strategy, besides, let's say, concurrently, to splitting these large operations. So how can we do? I put an example here. For example, it starts with alter table. I'm trying to add a table that is not null, and the default is a non-volatile function clock timestamp. I chose it on deliberately. So what does it do? It takes It takes access exclusive lock, and that means that we are actually holding the log for all this entire duration of the table rewrite. That's not nice, right? It can take minutes or hours depending how big your table. But instead of doing this one single operation, we can actually break it. In the other part, you can see that 3 steps I separated. So what did I do? First, I add the nullable column with a default. So I just say alter table, add this column, and then default this value, clock timestamp. And then while I did this, I, of course, briefly took the access exclusive lock because I can't avoid it. But then the second part, because I want to actually update these nulls, right? So I populate all this data, any null values if there is. I am actually doing this as not part of the initial. If I did it at the beginning, I will have to rewrite everything because I have to check everything. But this now I don't really do. I just do with this update, and I can actually do this update in batches because we don't want, long-running query. We don't want to get into the same story that we were mentioning before. So I'm doing this like population, and I'm doing them in batches. And then at the end, I'm actually adding null constraint. This has like some obvious advantages, right? Like we know that the first step that we did, it actually took a brief log, and then it actually served later on when we are actually doing the row exclusive with the update. We are able to serve is normally allowing the concurrent operations after that. And yeah, that's like usually when you have the this kind of operation, it's better to put them into steps and think about it, how the ways that we can actually improve the situation here, reduce the duration of the log that you are taking. Okay. And then in the next this page, we will talk about it. Is there any way that we could actually make this better? So I took the last comment there. It was the alter table, like alter column set not null, right? We ended up there, but it is still can take long, and it will still block the writes. So is there any way that we can actually make this better? Because it's actually still better than the one that we started in the first phase, like we having like directly setting not null with default and clock timestamp. We come to this like last step after dividing 2 to 3. But is there any way we can do it better? Yes, there is. So here in this example, we will actually use the check constraints. And while I edit in the, like at the C, you can see alter table. When I edit as in like not valid. And then I validate the constraint. First, I edit it. What does it allow me for? When I add this constraint as a not valid, it will not check the things that is prior to this. It will only check the new entry to this table. So I'm making sure that I'm not touching the like old information there. I'm just checking on the new inserts and what's happening new. And then once actually I created this, I did it like I didn't block writes while I do this. And when I validate it, validate doesn't block writes. That's what I mean. Sorry. So I validated later step. And then if I want after this, I can actually set the not null now, because Postgres is actually smart enough. It knows this is data. This check constraint is already valid. It is enforced. I know that if I add this that not null, it will still take the log, but it knows it's a very small meta operation at this point, because it's aware that there was a constraint that was actually having this information correctly, and then setting not null is okay. So then you can drop this. If you want to basically switch to that way of having it, if you want it as a not null column, then you can do it now, and then drop the other check constraint, which you should drop, because then it will be like keeping something that is not useful. And yeah, that will be basically easier that way. Okay, and this is like, it brings us to our basically fifth takeaway. Try to find an approach that doesn't really like lock everything unnecessarily, if you can avoid it. And of course, it will bring a little bit of planning. It will bring maybe, like thinking about batch size, batch time, how will we do this, and knowing a little bit of expertise too. But these things are very like available in the documentation. I mean, even this approach will take you from A to B easily. And yeah, Postgres manual has the concurrently statements, which you all know. But there are, of course, some things that it's kind of hard to directly to do it from SQL. And that's why we'll mention a little bit of in the pgroll section, because it allows you to do this high-level operations without like, writing raw SQL every time. So it will plan it for you, which we'll talk it later. Okay. And of course, I had to say this, Postgres keeps getting better. And if you are running a version, maybe that's already solved. The problems that we've seen, that might be already solved. And there are multiple, I think every version I see another concurrently being added. And we might not have the problems that we had it before already. So that's why I put one more example to show it. This is the example that adding a column that is not null and default is 1. Before, in Postgres, this would be also causing table to rewrite, but it won't now, because it is not, it knows that it is like a default value, and it doesn't really need to table to rewrite. It is just like a simple meta operation. So I don't need to really disrupt anything anymore, because if I was running this the other way that I ran before, not with like a default is 1, it's like, it's easy. And it's a constant value, so I store this information as metadata now. And that will allow me to just function normally. I will not need to block writes or anything. But it was before. So if you're running a older Postgres version, you might still have this issue. But if you are running a newer one, you probably, now you won't. So it's kind of important, I think, to know that just upgrading will actually help you even in this situation. Yeah, upgrade. Okay, and this is the almost final part of the talk, that we will talk about a bit this tool that we are developing in the company. It's pgroll. I said at the beginning, it's open source. It's Apache 2, so you can check it out, everything, use it. If you use it, let us know too. So what was the motivation, basically? I think up until now, we've seen the motivation. There are some things that needs to be managed, some things needs to be planned when you are planning your schema modifications. So this is of course, main modification. We've seen that there are logs, alter table comments, like really usually takes the exclusive logs. So this is like one of the motivation. And we also wanted to handle, let's say, when I was splitting columns, I had planned how to do the updates, and we call this backfilling. So this tool allows you to actually adjust this backfilling procedure, basically. You can decide, I will show in the examples like how will we do it, but you can actually say that I want this updated this way when I add this new column. When there are nulls, I want it to be filled it that way. I want to cast it this to that, so you can write functionality there. So it helps you with this kind of data backfilling, and also it will help you with the backward compatible situation. We actually have different operations to make sure you don't get downtime while you do these operations. And another good thing, I think, very useful, that while you do these changes, you can actually still serve your old application and the current new application that you are trying to migrate at the same time. So we will not disrupt anything, so it's good for blue-green type of scenarios. Okay, so how does it actually work? So we have multiple versions of the schema that we create. Imagine a scenario, let's say we are adding a column with not null. Let's say we have a column and we are trying to make it not null. And we still, in the table that we are using, let's say users table, I'm trying to add this not null. So what we do is that we create another table, another column that will have the not null functionality, but we don't touch the old column. So we still serve. How do we serve? We create multiple versions of the schema, and this schema is like you can search with your search pad. So your application knows if that is the old schema, it will continue. If it is the old version of the application, let's say the current application, we will serve it through a different schema that sees another view of the table, then the new one that will see another view of the table. So we will have multiple views on the same database, on the same table, that we will connect through different search paths. So when I connect from the older search path, I will see the version that before migration. When I connect through the new version of the search path, I will connect to the new view that actually shows the other columns that I'm trying to add or do the changes in the meantime. So that is like kind of how it works in real life. And there is also the triggers that we create every time when this migration is happening. So I can actually update both versions of the data. So we call this like dual writes. I think it's like a known concept, right? When you have this new, let's say not null, the new version of the app, when somebody tries to enter a null value, it will just block it, says, no, we have this constraint, I don't want to edit now, you can't edit. But the old version still has not have this constraint. It will try to actually, if you want to add a null value, you will edit. But we will take this data and transform it to the way that we want. We will transform it to something that when you are using, you can define how do you want it. And you modify this information with this up script that we say, up command in the SQL, I will show you soon. And then if there is a new information in this new version of application, I will take it down to the old version. So both of the applications will continue to operate smoothly while we do these things in the background. Okay, sorry. Yeah. Okay. And here in the example, I don't know if the code is so similar, it's visible, but yeah, the most important thing here is that we offer this high-level operation, so people just say in JSON, it's a debatable choice of management, but yeah, this is the initial version of pgroll. So you can do add column, rename column, whatever type of operation that you want to add, and it will reflect you. This is how you code it. And there is this up and down SQL commands, and you can just say, okay, I want, for example, here, I think the example is taken, I'm changing the column type from text to integer. So I want to have the casting as for the new application, I want to custom to integer. And if there is something like in the new one, I will bring them back as a text to the old application because that's what it expects. So we keep this backfilling through this up and down scripts. And the theory behind is that there's this pattern called automatic expand and contract pattern, which is very simple. Like instead of touching the existing columns and doing stuff in the existing way, the way that it works is that you actually first expand, which means that you do a new version of, like, if you want to have a new column with a new constraint or something, you just keep creating those things without touching the existing column that operates. And then at some point, we will see in the next slide, the multiple versions of the applications lives in the same time. So there will be multiple views that we are using, multiple schema versions. And once the migration is over, we have the new version. And that's why we call it the contract, is that once you complete the migration, you drop this edit columns that you edit, you delete, dropped all the triggers, and you have, so it's just kind of contracts the things. But yeah, this is, I think, a software pattern, and that is applied here. Okay, so this was the picture actually I wanted to show. Basically, you have this kind of red common part that at this point we are serving multiple versions. This is the point that actually makes things usable for people. You can test things, you can just make sure that nothing is actually using the V1. And then afterwards, you can say, okay, I'm completing the migration because it has 2 steps. We started the migration. We decided that everything is okay. We complete it. Or we can just say, okay, I didn't like it, or there's some issue with it. You can roll back. And while you do this, you continue to serve as you would. That's, I think, the most important aspect of it. And if you want to learn more, we have this new pgroll.com website. It explains how it works under the hood, and the docs are also in the repository. But yeah, the logic is sort of simple like this. And this example, I mean, it's not probably so clear, but I just wanted to show you that the main table is already main table here has this new 2 columns. For example, when we are, imagine we have a name column, full name. At the beginning, we decided as full name, but eventually we decided this is not covering what we want, so we want to have a last name. And there's an age column, but I don't want the age column. Maybe there are some null age columns coming, and I don't want it, so I want them to be not null. So I keep adding all these things in the basic table, the base table, and then I create these different versions of views and do this backfilling in the background. So I have 2 versions of the table mapped with these columns, and I know that things are happening in the background. And once it is over, when I decided that migration is to be done, I'll just remove these things. And this is to show, to show how we define it. You probably all know how to define the search path. And let's say, for example, in the first one, if I am actually allowing, this was the old one, the new schema version that I said at the beginning, let's say it doesn't allow the nulls. When you try to enter, it will just error. It will just say, okay, this is violating the constraint that you are trying to create. But if I switch back to the old schema version, and it will continue to get the nulls. But those nulls will be transformed if you actually decided how to transform those things. So it will continue the way. You can just query. You can see these nulls that you entered, but it will be actually in the background. In the new version of the view, you will see those things actually converted the way that you want it. So that's what we do. Automatic backfilling, I think, is important because also it takes the logic from the application layer in a way, maybe to database. So you handle all these things in your schema migration changes and data migration changes became the concern of database now, and you can handle it directly in the database layer. And of course, there are things that you can adjust the page size, and you can delay them. And so there are things that you can do around it in this high-level format, basically, which you wouldn't be able to probably achieve easily if you do it with Postgres, directly raw SQL. Okay, and we already mentioned this conversion of data up and down. Anyway, you have to do this if you are doing it yourself this way. You don't need to use the pgroll, but if you're planning it the way that either you need to handle in the application level, or you need to do splitting operation the way that pgroll handles. But it solves basically the main problems that we covered. If there's a way to not to acquire the stronger lock, we will have to handle it. We have this creating its invalid version and then validate it later and so on. These are all already implemented. And yeah, that's kind of, I think, helpful in that regard. And it also comes with set log timeout that I was saying. So for these operations, we already have it prefixed with set log timeout, this amount. So it will actually also help you with this locking queue issue example that we give. Here, it wouldn't be a problem. And when you need to retry this, it's also a part of the logic. So when you get the log timeout, if you set this, we set it, and we also retry it in case this happens. Okay. And the benefits, there's clear benefits having this view. What is the main point is the serving multiple things at the same time. If you have a rollback, you can revert it. It's easy because when I was working as a DBA, many years ago, planning these things, we had to have a maintenance window. I was working in a bank. It was not a fun thing. And you have to have like these versions of scripts. You have these scripts grow, and it became scary. People don't want to actually change those things anymore. Multiple teams are involved. There are some companies still doing that way, like there are like rollback scripts. It's written back and forth. It's like, it's error prone. This is also error prone. You are writing, for example, up and down scripts yourself, but it is less error prone probably than doing it directly. So it's useful to give it a try in that regard and see how it goes for you. Okay, so this was the final takeaway. I wanted to showcase that this information that we talked is already built in the tool. You can take a look or actually use the strategies that I shared. And if you want to see more, we have this new website, pgroll.com. It's special to this open source project. You can see the blogs. That is actually, this talk is inspired by the blog post that I started to write in the topic, and then I decided to make them a talk. And this QR code takes you to the repository if you want to learn more. And Dekui, this is the young girl who came to Prague many, many years ago and shows up eventually in the all Postgres-related events in Prague. And I'm happy to see that I feel like now I feel home. And this stage became like a very homely stage for me. So thank you for coming. Thank you for joining the conference in general. And hope to see you in the meetups too, if you're interested. Thanks.